This Zoom session is being brought to you by the Fractal Bullseye. Okay, for today, 3.7 and 3.8 ending chapter 3, which means that chapter 3 will be due next Wednesday. Anyhow, 3.7 is about rational functions, and 3.8 is about direct, inverse, and joint variation. A rational function is a ratio of polynomials, p of x over q of x, where p and q are polynomials. And okay, this will be about graphing it. For example, what's the y-intercept of this? Well, it's 0 by r of 0. So that's easy enough. If the numerator, p of c equals 0, then r of c by 0 is an x-intercept. So here's the y-intercept, here are the x-intercepts. Now, asymptotes are where instead of being equal to where x is 0 or y is 0, is where x and y equal or approach infinity. So, for example, here's a function y over x, clearly a rational function, ratio of 1 and x. It has a form of this form called a hyperbola. If you tilt it by 45 degrees, you get the shape. That a lamp with a cylindrical shade casts on the wall. Anyhow, x equals 0. This vertical line is the vertical asymptote. Here, y approaches infinity when x approaches 0. So we denote that by this. Y equals 0 here is the horizontal asymptote. That's where when y approaches 0, when x approaches infinity. Denote it this way. All right. Now, if we have a rational function and the denominator is 0 at c, then x equals c is a vertical asymptote, because that's when we're dividing by 0, yielding as infinite value for y. Now, for horizontal asymptotes, it's a little more complicated. We have this polynomial over this polynomial, the nth degree polynomial divided by an m degree polynomial. Then it matters what happens when what happens depends on n, m, an, and bm. If n is less than n, if the numerator is of lower degree than the denominator, then when x approaches infinity, x to the n approaches infinity slower than x to the m does, and the ratio approaches 0. So if n is less than m, the horizontal asymptote is y equals 0. If n is greater than m, then the numerator approaches infinity faster than the denominator does when x approaches infinity. And so the ratio is infinite, so you don't have a horizontal asymptote. You may have what's called a slant asymptote, but that's a slightly different issue. And if n and m are equal, then you can divide numerator and denominator by x to the n, and all the other terms vanish, and we're left with n over bm, or an over bn, if n and m are equal. So for example, what are the intercepts and asymptotes for this? 2x minus 3 over x minus 2. Well, okay, at 0, these terms cancel, and we're left with, oh, it's 3 halves, not minus 3 halves. I have to change that. So that's 3, 7, 15, y-intercept equals positive 3 halves, my error. When now the numerator, the t of x is 0, when the numerator is 0, and that's also at 3 halves. Curious coincidence. Okay. Now, tx is infinity for a vertical asymptote when the denominator is 0, x minus 2 is 0, namely when x is 2. So 3 halves is an x-intercept, 2 is a vertical asymptote. And finally, for a horizontal asymptote, we'll let x approach infinity. Then 2x minus 3 over x minus 2, the trick is to divide numerator and denominator by the highest power, x. And we'll get 2 minus 3 over x over 1 minus 2 over x. As x approaches infinity, the 3 over x and the 2 over x go to 0, and so we're left with 2 over 1, or 2. So y-intercept is positive 3 halves. I have to change that. Y-intercept, x-intercept is at 3 halves. The vertical asymptote is at x equals 2, and the horizontal asymptote is at y equals 2. Now do the same for x minus 1 over x plus 4. At 0, when x is 0, you get negative 1 over 4. So that's the y-intercept, 0 by negative a quarter. R is 0 when the numerator is 0. X minus 1 is 0, so x equals 1. 1 by 0 is the x-intercept. R is infinite for a vertical asymptote, where the denominator x minus 4 is 0. So when x is negative 4. So x is negative 4 is the vertical asymptote. And when x approaches infinity, then the polynomial, the rational function x minus 1 over x minus 4, we divide numerator and denominator by x. You get 1 minus 1 over x, or 1 minus 4 over x. When x approaches infinity, these approach 0, and we're left with 1 over 1, or 1. So y equals 1 is the horizontal asymptote. Now here we have a visual thing, identify the asymptotes. The vertical asymptote is here when x is negative 2, and here when x is positive 2. The horizontal asymptote is this here at y equals 1. Now, here we have a somewhat more complicated one, fortunately factored, find vertical and horizontal asymptotes. For the vertical asymptote, we want when s is equal to infinity. That's when the denominator equals 0, because dividing by 0 yields infinity. So 3x minus 1 is 0, or x plus 2 is 0. And after a little bit of algebra, x is 1/3 or x is negative 2. Those are the vertical asymptotes. Now, for a horizontal asymptote, first we'll expand both polynomials and get 5x squared plus 4x minus 1 over 3x squared plus 5x minus 2. Now, the terms after the leading terms don't really matter, because we'll divide both numerator and denominator by x squared. You get 5 plus 4 over x minus 1 over x squared over 3 plus 5 over x minus 2 over x squared. All these terms over x go to 0 when x approaches infinity. So the result is 5/3. There it is. So 5/3 is the horizontal asymptote. Now, okay, let's go through the same thing. Find the intercepts, the asymptotes, and the graph of s of x equals 4 minus 3x over x plus 7. All right. So for the y-intercept, set x equal to 0, plug it in, out comes 4/7. 0 by 4/7 is the y-intercept. For the x-intercept, the function is 0 when the numerator is 0. X minus 4 minus 3x is 0. After a bit of algebra, x is 4/3. So 4/3 by 0 is the x-intercept. S is infinity for a vertical asymptote when the denominator x plus 7 equals 0. And that means when x is negative 7. So x is negative 7 is the vertical asymptote. And to find the horizontal asymptote, take the function, divide numerator and denominator by the leading power of x, namely x. Get 4 over x minus 3 over 1 plus 7 over x. The 4 over x and the 7 over x vanish when x goes to infinity. So left with negative 3 over 1, or negative 3. So x is negative 3 is a horizontal asymptote. So you have intercepts and asymptotes. And the sign, oh, it's a good thing to do the sign graph. Where is it positive, where it's negative? Above 4/3, it's negative. Between negative 7 and 4/3, it's positive. Below negative 7, it's negative. So, okay, here's the line x equals negative 7. Here's the line y equals negative 3. Here's 4/3 by 0 and 0 by 4/7. So it's positive through 0 to negative here and negative throughout here. And this is not that good a graph, frankly. I really should change that. Graph, page 9. Perhaps I'll change that in the Canvas as well. Okay, so that is that for that. Let's let's stop.